Yeah, go away. Okay. Hello.
Hello, how are you?
Hey, we're all back. Yay. Hi, everyone. Welcome to this week's Learning Space. My name is Nicole Galucci with CosmoQuest. This is our weekly show about all things science and astronomy, education, and outreach. If you guys want to participate, ask questions, leave comments, you can do so using the Q&A app through Google+. If you're watching this embedded anywhere on YouTube, you can click on the Q&A app on the video to do that. I see a couple of you are commenting already. Hi, Nancy. Hi, Guido. I've seen an error from Jeff, but that the Hangouts seems to be having a little bit of a problem today, but we are running internally, so hopefully you guys can comment and let me know if we're coming through yet. So, okay, I know the comments are a little bit delayed, so just pop in when you can. I have with me today Douglas Arian, here, or here, I don't know what side he's on for you guys. Welcome, thank you for coming back to the show, Douglas.
Very welcome. Very happy to do this.
So you are from Carthage College and involved in the Galileoscope project, and I know you had some updates and things you wanted to talk about regarding the Galileoscope. So first, can you explain with Galileoscope for any new viewers who don't know what that is?
So hopefully everybody remembers that 2009 was the International Year of Astronomy.
Yay.
And for the, yes, great. For the IYA, there were a handful of worldwide, what were called cornerstone projects, the big efforts that were put in place to promote astronomy. And there was a group that thought that one of the most important things would be that everybody should have a telescope to go and look at the sky. But if you look out and you look at inexpensive telescopes, there was very little out there that was actually good quality and inexpensive. So a couple of us got together and designed a telescope to do that. It had to be very inexpensive. It had to be very high quality. We wanted to be a kit, one of education materials, and so we went ahead and did that. And to make a long story short, there are over 200,000 of them in 106 countries right now.
Wow.
That we've distributed. And if you go to the website, Galileoscope.org, you can order them by the case there. There's a list of dealers you can get them from. There are also links to a lot of education materials, lesson plans, observing guides, optics, exercises, all sorts of great things, and instructions, and I think we're up to 12 or 14 languages up there. So it's a really pretty exciting thing. So even though we did that for the IYA, we continue to distribute, and countries all over the world are still using them. Brazil, huge education effort there. They bought thousands from us. I was in Mexico last year. They bought 1,000 for the state of Yucatan for their schools.
Wow.
So yeah, it's all over the world. It's really cool. Very exciting.
That's excellent. We have a stash here. I'm at Southern Illinois University, Edwardsville. We have a stash here. And I think we may be ordering more. We're doing a summer camp called Eyes on the Universe, where the kids will be doing optics experiments and building their own Galileoscopes and getting to take them home. So I'm really excited to be on the planning end of that. And the Galileoscope makes it so that I like the build-it-yourself aspect. Having a little bit of instrumentation background, I like that and the fact that the kids can do experiments with it. So what's new? Are there any updates in the Galileoscope world? You said you have over 200,000 that have gone out. That's amazing.
Yes, exactly. So let's see, the big updates on Galileoscope. Well, update number one is we're still making them. We still have them in inventory. So if you need them for your camp, just order them and they'll be on their way.
Sure.
We're working with, is actually an engineering graduate from Lehigh to develop a little mount, an inexpensive ejection mount to go with Galileoscopes. We're still working on getting that design done and getting it quoted out and trying to get those produced. But it's something that's, we're hoping to bring out this coming year and have them for 2015, which is a big year that we'll talk about in a little bit.
Yeah.
And really, that's one of the next big things is the International Year of Light, and we're hoping to make Galileoscope a cornerstone project for that as well. So trying to bring optics education out there. So it's the same tool, but with new materials and new instructions and new activities to be used more as an optics education kit. But that's the big stuff that's coming along right now with Galileoscope. So we're planning another production run this year. So we have a few thousand in inventory, but we're hoping to make another big batch later this year. So that'll be pretty exciting.
That's excellent. I have a Galileoscope in my garage with my collection of telescopes that all live in the garage. And I was actually helping someone at a star party put together kind of a cheaper, smaller department store telescope last night. And I remembered using one of those telescopes as a kid and being really frustrated.
Right.
And the Galileoscope, although small, is super sturdy.
Yeah.
Which is really fantastic. And it's nice to just kind of hold it up and look, but you really do want a tripod. I've been using camera
Right. Right.
tripods. I think that's
Hmm.
I think that's what we're giving the kids in the summer camp. We're giving them camera tripods to do it with.
Well, we can link you up with suppliers of inexpensive but very good tripods. So let us know. If
Ooh,
you want to
that
go
would be
through.
really cool. I'll have to email
Definitely
you that.
contact us. We'll do that. And that's to the community as a whole. I mean, we have linkages to it, and I think there may be a link on the website. If not, we can send the information on that. So that's very cool. You know, it's fun to see what people have done with Galileoscopes. Go to do a Google Images search on Galileoscope, and it's amazing. You'll see people, firstly, all over the world, kids, adults, schools, everybody using them, and then there are other people who've gone and used them for things. So people are now using them to build autoguiders for their telescopes because it's
Mm.
the most cost-effective 50 millimeter refractor you can get, and they put their autoguider in the back in it and rings, and all of a sudden you have this, $10,000 telescope with a $25 Galileoscope on the side of it being the autoguider, which is
Oh,
pretty
that's
slick.
awesome.
You see them being used in a lot of different places, so it's very cool, very, very cool.
Yeah, I've even seen it used in cosplay. Pamela Gay had a steampunk astronomer costume, and she painted hers bronze to
There you go.
to
There you go.
carry around with her costume. Yeah, yeah. So that was really cool. Cool. So what's happening in 2015? What is the big event related to telescopes?
Exactly. So it's a great lead into that. So just as 2009 was the International Year of Astronomy, like 1956 was the International Geophysical Year,
Hmm.
2015 is going to be the International Year of Light, and that's being sponsored by the European Physical Society, EPS. Again, another worldwide experience to promote optics and photonics, which is really very cool when you think about the fact that, our most important, well, I can't say most important, but really important sense is sight. Vision and optics are a very important part of everything every day. So there are going to, again, be a series of cornerstone projects. They're still developing what they are that are going to be out there to promote light and optics. And light and optics includes things like, lasers and fiber optics, beyond, just telescopes.
Right, right.
But the Galileoscope, which was designed as an optics kit, fits into that really, really well. So we're hoping to be able to partner with that. So everybody should be on the lookout later this year, later in 14, for announcements of what the big global projects are going to be in 2015. But what a great opportunity to engage people with all sorts of things, because you can play with lenses, you can play with lasers, you can
Hmm.
get, optics effects in the atmosphere. It's cool to see a ring around the sun that's from ice crystals and rainbows and all these other things that are all part of optics. It'll be really, really neat and exciting. So it's another great opportunity for everybody to engage the public with science around the clock with all sorts of cool things that you could do.
That's really great. Yeah, it sounds like it's a really broad topic that covers a lot of different science and engineering disciplines. How did this get started?
To be honest, I don't know the who initiated that. I mean, I was part of the IYA, so I know all the politics of how that got put through the UN.
Right.
All international years have to go to the United Nations, and they certify it first, and then it goes out to the member countries who each then acknowledge that they're going to be part of the international year. So I'm not sure who started the
Okay.
IYL, but I said the European Physical Society is sort of the home base for it. So everybody should just, if you just Google, yes,
Yeah, if
EPS and IYL, they'll come up with the site
I
for it.
googled International Year of Light and the EPS site was the first hit, so that should and
Mhm.
I've included the link in the comments and they'll be in the show notes as well.
Great, great. So everybody should take a look at that and think about how they can engage with that. The nice thing about an international year is, as opposed to just doing an event that's just kind of, well, we're going to do this event, by promoting it through the international year, you get a bigger audience and an ability to link into other people that are doing really, really cool things. So here, compared to the astronomy side, here there's a definite industrial side to it, because there are companies that do optical things, whether it's LED bulbs to lenses to fiber optics, optical computing. I mean, there's so much stuff that goes on in optics. There's really a lot of opportunities to do cool things with people. So hopefully everybody will.
Excellent. Yeah, we have one of the physics professors here plays with giant lasers, so I'm sure he's going to find a way to get involved with that.
Absolutely. Well, I mean, from an astronomy point of view, anytime I do outreach programs, and we'll talk about that later, the thing that everybody loves probably more than anything else is the green laser pointer.
Yes! I was just doing that last night. They were like, whoa!
After you turn that on, it's like, what was that? Isn't that cool? It's like you're not even looking at what you're pointing at. It's like
Nope.
green laser pointer.
You have to have a few minutes just to introduce the pointer, because they're not looking at what you're pointing at. They're like, oh my god, lightsaber. Yeah.
Exactly. So, and actually, that's a great opportunity for people. Green laser pointers are out there. They're not that expensive. Having one, yes, you can do astronomy with it, but you can show all sorts of great things, using that because it's so bright. So that's very cool. So yeah, green laser pointers are a big hit with the public of all ages. It's not just little kids.
No.
Adults are like, what is that? That's so cool. Yeah.
Just really... be careful. Don't point in the direction of planes. Be safe. Follow legal guidelines.
Yeah.
There are some power restrictions on them. I don't know what they are right now, but I didn't get in trouble with campus police last night. So.
Well, that's good. That's good.
I was showing him the planets. I take out the laser pointer, and I was like, "Oh, I didn't think about that, did I?"
Exactly.
It all went well. It all went well. So, of course, light is a very important topic in astronomy. What are so Galileoscope is working it to be the cornerstone because light telescopes astronomy, of course. What other ways is astronomy do you think going to be folded in?
The other big area that I know is going to be worked on is dark skies preservation, which is using light in a healthy way as opposed to an unhealthy way. So not just that you get the sky back, but the fact that the misuse of light is actually an issue for the health of people, the health of animals,
right.
Energy expenditure, and so on. So that's going to be a big theme, I think, that's going to come through there. So Connie Walker, who's at NOAL, is going to be leading that. Also, the main IAU contact for the IYL is Richard Green, who is also one of the people in the American Astronautical Society Dark Skies Preservation Working Group, which is Richard, Connie, myself. So we're all part of that. So I try to participate in as many things as I can to promote this. So I don't know how many of your viewers, listeners know about the International Dark Sky Association, the IDA. It's darksky.org. If they don't know about it, they should know about it. It's very, very important for astronomy and energy saving and the environment, and people should look at that. There's a lot of useful information there. So that's going to be another part of the IYL, is getting people more to understand that light is good. Too much light is not only not good, it can be bad.
It's bad. Yeah, it could be dangerous. It's costly. It affects wildlife, and it affects astronomy. There's so much there.
Exactly. So there's a lot of reasons to educate people about that and good use of light. So hopefully that'll happen.
That's excellent.
I can get some people under there.
So of course, when I think about light, since my background's in radio astronomy, I think of it containing the whole electromagnetic spectrum. Is this going to be focusing mostly on visible, or is there going to be a wider wavelength range to the activities and types of focus that?
That's a good question. I know the main IYL area will be visible light. The working group that I'm on also addresses the whole electromagnetic spectrum. In fact, one of the things that's been brought up is the fact that now that lots of cars have little radar thingies in there so that you don't bump into the car in front of you, that actually is now going to create a whole new collection of radio pollution.
I'm crying.
The good news about it is the beams are very directed. The bad news is if you happen to be looking, down the bore side of an instrument, it's going to see it. The good news also is it's at ground level. Most of the time, radio astronomy, you're not looking close to the ground. But you do have sidebands. So that's one of the things you have to look at. Your arrays do have sidebands, which normally aren't an issue because you're not getting much in-band interference. Now you're going to have a new source of in-band interference. I'm sorry I didn't exactly make your day there, but it's something to look at.
No. Well, I mean, different observatories obviously have different ways of dealing with that. In Green Bank, they restrict what vehicles can even get close to the telescope. They only have the diesel vehicles, for example. Some of the diesel vehicles are from the 60s and still running, which is fantastic. And I think, the other, like the square kilometer array, both sites are being built in the middle of the desert.
Right.
So that's an interesting, goes along with dark skies awareness is quiet skies awareness. So you get kind of both sides there.
And in both ways, I mean, it's one thing to say, well, we're going to build the real astronomy facilities out in the middle of no place, but I mean, you run out of places in the middle of no place.
Yes.
And just because you say, well, we can protect the observatories by putting them someplace people aren't, well, that's good, but that doesn't really absolve the rest of the people from misusing the environment that's around them.
Right.
So hopefully we can do both.
Okay. Very cool. Very cool. Anything else relating to International Year of Light that we should look for?
Um, to be honest, they're really just getting organized now. So they don't have their Cornerstone project list up yet.
Okay.
That's coming. So it's one of those things that you should definitely check later this summer. I know there's a number of organizing meetings that are happening going, this month through June, the next 3 months. So after that, I think will be a good time for you to look and see what's coming up. But I think the important thing is for everybody as they think about next school year, for example, the 14-15 school year and the 15-16 school year, to know this is going on. It gives me an opportunity to talk science with kids, and it can be, as we said, optics is everything. If you're teaching biology, you can talk about, vision, but you can also talk about how ultraviolet and, the effects on skin and what's ultraviolet and where does that come from. And you can talk about, lighting and health effects. And I mean, there's a long list of things that you can do with light, no matter what area you're teaching. So I hope people think about that. Use it as a way to promote understanding. Would be great.
So can you talk a little bit more about Galileoscopes' uses in education?
Sure. So the first thing is that the Galileoscope is sold as a kit.
Mm-hmm.
And that was intentional. It wasn't just a matter of, well, we can make it cheaper if it's a kit. Actually, it's harder to make when it's a kit than when it's a whole telescope. So, but as a kit, the idea being that as you assemble it, you, well, first, see all the parts that actually go into one. If you just get a telescope and you start looking through it, you're not aware of the fact that there are all these different lenses and what they do, for example. Mm-hmm. So by putting it together, you put in the objective and find, hey, wait a minute, this is two lenses together. Why is that? And you can learn about how lenses are put together, and the eyepiece and the Barlow, all the different lenses that go into it. So it was always intended to be something that you learned how telescopes work and how optics work by putting it together. So that was one of our main goals. So you can use it as, we're going to build a telescope and learn how telescopes work and do that part. You can say, we're going to learn how lenses work. So as you put it together, you say, well, this is the main lens in the front. What does it do? You can hold it up and see that it makes a real image, and then you can look at that image. You can do a lot of different things with it. You can learn about, well, what we call chromatic aberration, that one lens doesn't put all the colors together, but if you put two lenses together, you can make most of the colors come together. You can actually see that, and so on. You can do a lot of those things. So it's really great. A number of people have written lesson plans to do that. They're linked on the resources link on our website. So if you're doing a class, you just have a kid at home and say, oh, let's get a Galileoscope and put it together, you can do more with it than just, well, we're going to put it together and have a telescope. So we try to do that. So that's one thing that goes on. The second thing is that one of our major consumer groups, if you will, has been education organizations. So I mentioned to you at the end of 2012, I was down in Yucatan. So they were having a big festival because it was going to be the end of the world, if you remember.
I do. I was in a 24-hour hangout for that.
It was really pretty cool. We made it. So they certainly took advantage of that, since it was a Mayan prediction, and that's the center of Mayan culture. They had a lot of things. But they bought 1,000 Galileoscopes to put into the schools in one state in Mexico. And the point was, teachers should know how to use these and then be able to teach their kids about optics and astronomy and so on. And of course, the Mayan culture was very tied to astronomy, so it all works together really, really well. Brazil, same thing. Lots and lots of Galileoscopes going into schools. Pakistan bought quite a few to put into their schools. There are a couple of universities in the United States that buy them and use them in their classes. It's a great thing for introductory astronomy classes to buy them along with the textbook. You build a telescope and the student walks away with a real telescope at the end of intro astronomy. It's a really great thing to do. We haven't gotten too many schools to do that. I think it would be much better if they did. I think it's a better thing to get than a lot of the other things. It excites people. They put it together. They go look at stuff. I think we'd like to see more people doing that. So, one of the major goals of the project was always to do science education, and I think it's going okay. I'd like to see more, but you can never have too much. So we can go from there.
All the science education. So it looks like the Teachers for Telescopes program is still going along. Can you tell
Yes.
us a little bit about that?
So we launched together with Astrosphere New Media donation program. So during the International Year of Astronomy, people could buy Galileoscopes, but they could also donate money
Right.
and have telescopes sent out. And what we did there was enough money was donated to send 7,000 telescopes, and they went to South Africa, and then they distributed them for free all over the place.
Wow.
What we launched in 2012 was the Telescopes for Teachers program.
Mm-hmm.
So people can make tax-deductible donations and designate a school or a teacher to get a Galileoscope. So if they donate to that, we'll then send a Galileoscope to that teacher or school. And we've hoped that would be a way to get more Galileoscopes into schools. There have only been a few donations. I wish more people would do that. It's a way to really help science education, because teachers don't have the money to go buy them. You sit there and say, well, classes should have them. They don't have the money. Yeah. But the parents, you look at it and say, hey, look, for not much money, we can put, a bunch of these in the classroom, and then they'll be there forever. It's not like, they get used up. So we'd like to see more of that happen. But that's telescopesforteachers.org, telescopesdigit4teachers.org. And we're hoping to do, another big version of that for the IYL. So we're looking at something like that.
So if you already have a Galileoscope, and I know a couple of people have been commenting that they either have a Galileoscope or they have other telescopes, you can still donate one. So that's really important. We also have a comment from Jeff Setzer, who recognized
I know you.
He recognized my T-shirt and said, "Nice T-shirt. We've used Galileoscopes at teacher workshops at Yerkes." So that's the T-shirt I'm wearing.
It is indeed.
I visited recently. There's also looks like a new Galileo workshop program. Is this also going along with the educators?
It is. So there are two gentlemen at National Optical Astronomy Observatories, Steve Pompey and Rob Sparks, who have done a lot of Galileoscope workshops. Most of the ones they've done have been sponsored either by the Arizona Science Foundation, I forget what the exact name of it, but there's a big foundation that does it, and through Rockwell, which has sponsored a lot of them in the Tucson area. And so they'll buy a batch of Galileoscopes, then do a workshop with teachers, and then a star party so that everybody gets out under the sky with them. It's been a terrific program. So we said, hey, look, there's a lot of people who are getting Galileoscopes, schools, museums. It might be useful for them to be able to have a workshop like that so that people actually learn how to put them together, learn how to use them, learn how to teach with them. So we're offering those workshops. It's partnered with the gentleman I just mentioned, so an opportunity for people to say, hey, look, we want to buy a bunch. Well, we'd really like to train our teachers. What could you do? And they could approach us, and we would make that linkage so that they'd have the opportunity to get that kind of training. So hopefully some folks will sign on to that as well.
That's great. Yeah, so I got to that right from the main Galileo website over on the sidebar. You've got 2-day workshops, 1-day workshop, or online workshops. So if you have, if the trainers are nearby, you can have someone come out to you, or do it online, which is a really excellent avenue. So, and then you can add on a star party, which is always the most fun of part of putting it together, is then hoping for clear weather so that you can actually take it outside and use it.
That's right. That's right. So hopefully clear weather. So you said you did a little workshop yesterday, and you actually had clear weather, which is pretty cool, because that doesn't always happen.
It was every 2 weeks I do a star party on campus, and weather dependent, and the last 4 have been clear. We've been really we started off really bad, having to cancel one after the other, but the last 4 have been great. So we have a bunch of high school students that are taking an astronomy class, and their teacher requires them to come to the observing sessions. So that's really great. We just have an 8-inch Celestron out there, but it's been fun.
That's great. That's great.
Yeah, yeah. Speaking of observing, do you want to talk a little bit about the program that you're doing? I think we wrote a post about this on CosmoQuest, the outreach event you're doing, the Appalachian outreach event.
Right. So my main, well, I don't know main job. I have so many jobs, I can't decide which one is the main job. But that which absorbs a lot of my time is a large public education and outreach program that's funded by NSF that is a joint project between Carthage, which is the school that employs me, and the Appalachian Mountain Club, which basically runs all the nature and outdoors programs in the Northeast U.S. They were founded in 1876 as the country's oldest and most established nature education, nature preservation, outdoor recreation organization in the country. I approached them a couple of years ago and said, well, you do all these great nature education programs, but you don't have astronomy. Would you be interested in that? And they thought it was just a wonderful idea.
Excellent.
So I got NSF to fund it. So Carthage physics and astronomy students who do research with me, so I was just a kid peek a week and a half ago, as a matter of fact, where, by the way, we got one night out of 3 clear.
Oh, gosh.
Well, we got one night, and we can't share screens because I just crunched up the main image all night on one planetary nebula that we're studying. But
there is a screen share option over on the left.
There's a screen share option on the left. This would be kind of cool. We can show people.
It looks like a little green with an arrow.
Green with an arrow. Coolness. There we go.
Ooh.
So can people see that?
Yeah, I've put that on the main screen. What is that we're looking at?
So that is a planetary nebula denoted NGC 2371 and 2. So we'll do a little astronomy here in the midst of all this. But the NGC catalog is a list of objects that were mostly found by William and John Herschel back in the 18th century. And can they see my mouse moving too? Is this real?
Yes,
okay.
I can see that.
So you see this blob here and that blob here. Those were the only 2 things they could see, so they gave it 2 numbers. This is 71 and 2372, because they couldn't tell that it was all part of this one big thing.
Yeah.
And this is a planetary nebula, so that's the white dwarf right there, the remnant that's left, and this is basically its guts that have spewed out and is now illuminating with the ultraviolet coming from here. And planetary nebulae are very cool. They're very cool. Firstly, they don't last very long. This will be visible for 10 to 15,000 years. Which
that's a blink of an eye, yeah.
For something that's been around for billions of years, something that lasts 10,000 years is next to nothing, number 1. Number 2, only low-mass stars like the sun make them, so the sun is going to do this. So 4.5 billion years, we're done. It's all over. The sun's going to do this. We're toast. So get your affairs in order. You've got 4.5 billion years left. They have some oddball shapes. This is one of those shapes. They come in about half a dozen different shapes, and nobody knows why. We still don't understand the different shapes that they have. And they're very hard to get a distance. Most planetary nebula distances are unknown.
Oh, wow.
There are no standard candles for them. White dwarfs come in many different brightnesses. These come in different sizes, different shapes, different speeds. So there's been a lot of work done to try to understand how far away they are, which you'd like to know, because then you can figure out other cool stuff. So this particular one we've been studying, we did a study of this a number of years ago. One of my students took a lot of data on this in oxygen-3, doubly ionized oxygen, to study the emitting gas. She is now, having graduated a few years ago, she is now an operator on the MMT, the world's 8th largest telescope, I think she operates. Oh, one of my students. This is in hydrogen alpha. Okay, so this is in the red. And what we're going to do is we're going to composite this with the images that we took in oxygen-3, which tracks hotter gas, to try to understand, in this case, what's closer, what's farther away, what's the 3D structure. Because we don't know what it looks like in 3D. And that's what we're trying to figure out. So this is about 2.5 hours of exposure with a 1-meter telescope at Kitt Peak.
Wow.
Well, that's the total exposure over many sub-exposures.
Right.
And I just composited it this morning because it takes a while for the machine to crank through it, so I set it up while I was doing other things. So that's all I can tell you now, because we haven't done anything with it except we finally got it all composited from last week's run.
Look at that, guys. Fresh data off the telescopes.
Absolutely. Very, very fresh data. So anyway, let's see. I don't know how to get back on here.
You can click screen share again, and it'll go away. Woo, it stretches funny. There we go.
Okay. So in any, we got a little off track there, but this Carthage students who've done research with me are eligible to be interns with me in the outreach program. So 2 or 3 Carthage students spend the summer with me in New Hampshire with the Appalachian Mountain Club doing public education and outreach. They have telescopes set up all day and every night, as long as it's clear. They do solar observing, they do stellar observing. We do programs for camp groups, visiting groups. We train all the AMC guides, naturalists, hut crews. So I'm doing a program Saturday evening for 150 of their naturalist volunteers. They have a group of volunteers who do programs, so I'm training them. We've installed telescopes. Oops, sorry about that. Hopefully that will go away.
Do you need to get that?
No, I don't. I just don't want it to be making noise in the background. We'll just have to live with it. So I'm doing a program to train 150 of their volunteers on Saturday. We have telescopes installed at all of their facilities, including their high mountain huts up in the White Mountains. Mm-hmm. So we reach the first. This is the 3rd year of the program. The first year we did programs for 3,000 people. Last year it was 5,000. We're gunning for 10,000 this year. Okay, you can be quiet now. Thanks. Fuck the technology. It works.
Why it happened?
Yeah, exactly. So anyway, that's my major effort now, is doing public science education, because it's desperately needed. The programs that I run when I do the public lecture programs, I always tell people at the beginning it's the most atypical astronomy presentation they'll ever hear, because it's astronomy, but it's much more tied into one unified picture of how nature works, that things aren't the way they are independent of what's out there. The fact that human color vision exactly matches the spectrum of the sun at 6,000 K. Right. I point out to them, for example, the movie Contact, if anybody remembers Contact, and Jodie Foster allegedly goes to a planet around Vega. Well, she wouldn't be able to see.
Spoiler alert!
Yeah, spoiler alert.
It's only been out for 20 years.
It's only been out for 20 years. But I mean, for example, Vega's a much hotter star than the sun. Her eyes wouldn't work very well. The spectrum's wrong. So pointing out that humans have evolved in a particular way to match what's out here. The sequence of events that includes at least one supernova and several AGBs to produce the isotopes that we have here that we need to live, to have calcium for strong bones and teeth, as they say. Mm-hmm. The fact that that's all one story, and that's what we try to promote to people, to understand that it's not us and then there's astronomy. There's one big system. We're part of it, and as we talked about with that planetary nebula, in 4.5 billion years, we're going to get vaporized, and our parts are going to go out and condense to form some other star and planet somewhere else. Right. Well, we know we have, dinosaur blood in us from a prior planet somewhere else. So it gets people's interest, and I think that's important. And another big thing we do a lot of dark skies education as part of it as well. Because a lot of people have come up to the White Mountains, they've never seen a clear sky before. They've never been in a dark sky. Yes. So it's a pretty exciting thing to be able to do, and then explain why it is that they don't see that everywhere, and how to fix it. So we do a lot of that as well.
Yeah, I had that kind of experience in high school, and it was just, and then again in college, and it just blew me away. Just to see because I grew up in a city, to see a dark sky for the first time, having had an interest in astronomy all my life, was really mind-blowing. Like, oh, you could actually, this is the Milky Way you guys were all talking about. Yeah. I didn't believe it.
Well, there's a famous story. It was in the 80s. I forget what year it was, but there was a big blackout in Southern California. Mm-hmm. And this was height of the Cold War, early 80s, and the National Guard offices, the hospitals, and the police, they were all inundated with phone calls from people who wondered if LA had been nuked, because the lights had gone out and there was this eerie glow in the sky.
Oh my goodness.
It was the Milky Way. They'd never seen it.
Wow. Yeah, I mean, the power went out in 2003 on a big chunk of the East Coast, and New Yorkers didn't know what to do with themselves. I was thrilled, of course. I dragged everybody outside, but it was amazing to actually see so many stars above the city.
Yeah, that's
it was incredible.
Cool.
Yeah, hopefully, blackout's not a good thing, but there was a silver lining. So how can people get more information about these programs?
Okay, well, let's see. For all the things, Galileoscope is galileoscope.org, mm-hmm. Telescopeforteachers.org, and I know you'll post those things up. Mm-hmm. You've already put up the link for the International Year of Light, which is very cool. For the AMC programs, the AMC's general site is outdoors.org.
Okay.
I highly recommend people just look at that. And then there's going to be outdoors.org/astronomy which is a page we're just creating now. So if you go now, it's just a schedule, but we're going to be putting up a full page about the astronomy programs in the next week or two. And we also have a lot of resources up for the outreach program at a site called amc-astro.org, amc-astro.org.
Okay.
And folks are welcome to go there. And in fact, all the slides I use in these presentations are posted there, and links to sponsors and links to the IDA, all sorts of things are there. So we welcome visitors.
Excellent. That's really cool. We have a question while I'm sharing links from Jeff Setzer. Hi, Doug. I've got a case of Galileoscopes that will be a seed for a new and hopefully ongoing program at ncsf.info. Any recent programs you've seen with a handful of Galileoscopes?
Programs.
Yes.
You're talking about outreach programs, or what?
That's what it sounds like. Yes, Northern Cross Science Foundation. Yeah, it looks like outreach programs.
Yeah. Well, there have been a suite of them that have gone on. The Astronomical Society of the Pacific, ASP, has distributed them through Project Astro. That's one of the main ones that's gone out. We use them, of course, with the AMC program, the programs that Steve Pompey does at NOAO, and I know he'd be very happy to share what they do and how they do that. So they could easily contact Steve, and that's spompea, S-P-O-M-P-E-A, at noao.edu. And I'm sure he'd be happy to provide information on what he's been doing. So those are some of the big established outreach programs that are being done with Galileoscopes there. There is an entire workbook of things to do with it that's up on the website, so do take a look at that. That was put together by Tim and Stephanie Slater from the University of Wyoming. So they're welcome to go. That's downloadable right from the site, so that's a good place to go for it also. And Jeff has my contact information. He's welcome to email me, and I'll give him more information or stuff if he'd like to have that. I'd be very happy to help out.
Very cool. Very cool. Yeah, I've done some of the activities actually at the last ASP meeting, I think, or the one before. I can't remember. Rob Sparks was running a workshop showing the hands-on activities that you can do with the lenses from the Galileoscope before you actually put it together to teach optics. So I'm hoping to bring some of that to our summer camp here.
Yeah, that's great. Rob does an amazing job. He's absolutely the best at doing programs with Galileoscopes and optics. So they have the whole hands-on optics kit.
Yes. Yes.
An even more extensive optics program is the hands-on optics kits, and I highly recommend that to people. There's also a dark skies preservation kit that NOAL puts out.
That's right. Yes. Connie showed us that on a previous episode. She had the whole setup, and we turned out the lights and went through with the little street lights and all of that. Is that what you're thinking of, with the little street lights and the building?
Right, that's a great demo. Yeah.
Yeah. We did that on video. That was pretty cool.
What I'm trying to do with her, we're trying to improve the kit. Because one of the things I'd like to do with the kit is, so you have the little mag light, that's the street light, and you can't see the little man, then you put the cover on, you can see the man. What I'd like to do is to be able to put the cover on and cut the voltage in half, to show that when you have a cover, you only need a bulb that's half as big to put the same amount of light on the ground.
Yeah.
So that's an improvement we're going to try. We have to figure out how to engineer that, but a way to put a dimmer bulb and show that you get more light on the ground with a dimmer bulb. So not only should you cover it to get the stars back, but you can also use a smaller bulb that uses less power and lasts longer.
You should be able to put like a variable resistor in there.
Something like that, yeah. Modify it to do that. We're going to come up with a way to do that. So anyway, that stuff is great, and we love doing those demos with people. And people get it. When you show them that, they go, oh, okay, I get it now.
Yeah. I mean, it's rare. I mean, people have all. I mean, I think people have all had that moment where they're blinded by a streetlight and can't actually see what's going on in front of them. So that bringing that home with that demonstration is really important.
Yes, absolutely. Very good.
Safety is one of the big concerns when you talk about reducing light pollution. I think that's communities usually their biggest concerns.
Oh yeah, safety, health, and money. I mean, protecting the sky is not, your average mayor doesn't care, but if it's safety, health, and money, in reverse order, money, health, safety, that's what usually gets people's attention.
Yeah, excellent. Looking ahead to see if there are any other questions. I know we've had a whole bunch of comments You guys were working out. So apologies again if anyone's watching this after the fact and you couldn't get it to work during. Hangouts is doing something slightly funky today. So hopefully you can catch up on the YouTube channel or the audio version on 365 Days of Astronomy. What else? Q&A app. Guido Pieper says, full disclosure, I don't have a Galileoscope, but I've always wanted one. It's never too late, Guido. But he has a little Newtonian that's always been enough for him. So that's cool. And also, laser pointers can get you into jail here in Germany.
Yes.
Gotcha. Good to know. Don't bring the laser pointer to Germany. And yes, outreach from Jeff in your question, clarifying your question. So that's all cool. So if you have any last minute questions, send them in to us. Do you have anything else going on that you want to promote or share with people? We've got a whole bunch of links to go in the show notes for this episode, so I'm really excited. The resources.
Yeah, we'll try to get people connected. Well, one thing for people to think about with graduations coming up, Galileoscopes are great graduation presents.
Ah, okay, there you go.
If you have a kid who's interested in science, you'd like to get interested in science, if you buy them directly from us, they come by cases of 6, but if you get a couple of neighbors together or whatever, or you got a couple of kids, it's not, I mean, 6 isn't that many to distribute. Right. But, you know, that's a great opportunity to promote science with kids, and it's a good gift because it's not just a toy that they'll use and then outgrow. It's something that they can use indefinitely, hopefully. You know, we want it to be the entry-level drug to a great addiction to astronomy, and hopefully that will do it. So people can think about that. This is the season for that. It's the end of April. High school graduation, you know, middle school graduations, high school graduations, college graduations coming up. Think about that as a way to promote it. And, you know, everybody who's on here now has an interest in astronomy. They wouldn't be listening to us if they didn't. That's a great way to promote it. So I urge them to do that. And know that we're volunteers running it. We're not only not making money, we've sunk the money in to make it. So yes. It's not the same as supporting a commercial venture. It's really something that's being done to promote astronomy. So I hope folks will do that.
Excellent, excellent. Well, thank you so much. I'm going to put out a few announcements, and then we'll wrap up maybe with one last final thoughts about the upcoming International Year of Light and what that means to you. But first I'll do some announcements. Today is Wednesday, which means the next Hangout is Friday at noon Pacific. That'll be the Weekly Space Hangout hosted by Fraser Kane. We'll be talking about the top news stories from the week. I say we, I don't mean me. I am going to be getting prepared for the big Hangout-a-thon. So this weekend, April 26th and 27th, we're starting Saturday, about 10 a.m. Central Time, so that's, I don't know what that is, GMT, 5 p.m. GMT, and we will be doing a 36-hour hangout. Wow. It'll be myself, Pamela Gay, Phil Plate's involved, Fraser Kane's involved. I have no idea what else is going to happen because I haven't seen the schedule yet. I'm just gonna throw myself in there with everything. But we are. I've been on the back end for booking a few last-minute guests this week, so we're gonna have some really fun guests again. We are going to have some crafts, some science-y related crafts and maker things. It's going to be a lot of fun. This is all to help us raise awareness of science and astronomy education and to raise money to keep the CosmoQuest Citizen Science going, because we, of course, have just released some really amazing science results, and we definitely want to keep going and recruit more citizen scientists to the cause. So that's this weekend. Check the CosmoQuest page on Google+. I've been tweeting videos from last year's Hangout-a-thon, you know, memories, remember when, and all of that. There'll be a virtual star party Sunday, whether or not it's there may be a virtual star party tied in with a Hangout-a-thon, assuming we can get clear skies for some of our observers, but then the usual virtual star party happens Sunday night at about 8 p.m. Pacific. And then Monday, assuming that we're not all dead from the Hangout-a-thon, is the recording of Astronomy Cast with Fraser and Pamela. Next Wednesday on Learning Space, Georgia will be back. Georgia and I will be talking about telescopes for Tanzania, so a particular program getting telescopes out to Tanzania. So we hope you can join us next week for that. Douglas, hopefully you'll be able to join us for the Hangout-a-thon. I don't remember what
we'll try. As I said, I'm going to be spending most of my time doing a big training program.
Oh, that's right.
So I will be doing, accomplishing what we're all trying to accomplish here, which is
Yay.
spreading astronomy to the world. So
Excellent.
I probably will not be available, but I will try. I'll try to take a look at it.
Okay, sounds good. Sounds good. Thank you so much. Do you have any last words about either Galileoscope or Year of Light or any of that?
Just do look at all the various links that Nicole's putting up so you can see what's going on. I'm happy to answer questions from anybody, so please feel free to forward those to me. Information anybody would like on those things, I'll be happy to link them up to it.
Excellent.
So let me know how I can help.
Great, great. Do you have a contact, a way people can contact you that you'd like to share?
The email address is the best way, and that's just darion, D-A-R-I-O-N, at carthage.edu. That's the best
Excellent.
way to reach me. And I
All
will do
right.
my best to get back to you as soon as I can.
Excellent. So we got a thank you from Nancy Graziano. Thanks for the great show. I can always count on it being information and educational. Thank you, Nancy. And we will see you guys next week. Thank you, Douglas.
You're very welcome. Take care.
You too. Yeah, go away. Okay. Hello.
Hello, how are you?
Hey, we're all back. Yay. Hi, everyone. Welcome to this week's Learning Space. My name is Nicole Galucci with CosmoQuest. This is our weekly show about all things science and astronomy, education, and outreach. If you guys want to participate, ask questions, leave comments, you can do so using the Q&A app through Google+. If you're watching this embedded anywhere on YouTube, you can click on the Q&A app on the video to do that. I see a couple of you are commenting already. Hi, Nancy. Hi, Guido. I've seen an error from Chef, but that the Hangouts seems to be having a little bit of a problem today, but we are running internally, so hopefully you guys can comment and let me know if we're coming through yet. So, okay, I know the comments are a little bit delayed, so just pop in when you can. I have with me today Douglas Arian, here, or here, I don't know what side he's on for you guys. Welcome, thank you for coming back to the show, Douglas.
Very welcome, very happy to do this.
So you are from Carthage College and involved in the Galileoscope project, and I know you had some updates and things you wanted to talk about regarding the Galileoscope. So first, can you explain the Galileoscope for any new viewers who don't know what that is?
So hopefully everybody remembers that 2009 was the International Year of Astronomy.
Yay.
And for the, yes, great. For the IYA, there were a handful of worldwide, what were called cornerstone projects, the big efforts that were put in place to promote astronomy. And there was a group that thought that one of the most important things would be that everybody should have a telescope to go and look at the sky. But if you look out and you look at inexpensive telescopes, there was very little out there that was actually good quality and inexpensive. So a couple of us got together and designed a telescope to do that. It had to be very inexpensive. It had to be very high quality. We wanted to be a kit. We want to have education materials. And so we went ahead and did that. And to make a long story short, there are over 200,000 of them in 106 countries right now.
Wow.
That we've distributed. And if you go to the website, Galileoscope.org, you can order them by the case there. There's a list of dealers you can get them from. There are also links to a lot of education materials, lesson plans, observing guides, optics, exercises, all sorts of great things, and instructions, and I think we're up to 12 or 14 languages up there. So it's a really pretty exciting thing. So even though we did that for the IYA, we continue to distribute, and countries all over the world are still using them. Brazil, huge education effort there. They bought thousands from us. I was in Mexico last year. They bought 1,000 for the state of Yucatan for their schools. Wow. So yeah, it's all over the world. It's really cool. Very exciting.
That's excellent. We have a stash here. I'm at Southern Illinois University, Edwardsville. We have a stash here.